What you've seen so far is that we were building desktop focused application. We're building single machine based applications so far, and sharing these application with somebody else gets a little tricky because they have their own platform, their own operating system. They won't have the same environment as you, and sharing code across machines is tricky. One The way to solve it is that you provide access to your code on the internet to the consumers of the application. Now, there are two ways of doing it. The first way is using SOAP. SOAP is Simple Object Access Protocol. It dictates that there should be a specific pattern, there should be a specific mechanism through which you are expressing the service that you have and the response that you're going to give. Now, for a service like a calculator, you can create an extensive document based on XML, and that document is called WSDL, which is Web Service Definition Language. And then this visual document is going to be an XML document, and this document will provide you the methods that it is exposing and the response to expose from that service. Then we saw another implementation, another method of exposing services on the internet, and that was okay. I used the wrong word. Then we saw another mechanism. And it's called REST. So REST is REST is not a protocol. REST is a way of doing things. It recommends that when you want to create applications that are distributed, that are running on separate computers, right? What you should actually be targeting is you should try to transfer the state from the application looking like one thing to another thing, and it is the transfer of these states of the application, right? And then when you build web services using this particular way, those services are called RESTful services. Now, RESTful services or REST services, they work on HTTP, and I'm going to try to explain what HTTP is. So HTTP stands for Hypertext Transfer Protocol. Right. Once again, the word protocol, it means that it is agreed upon. It is the rules have been laid out, and it is dealing with transfer of hypertext. Now, text itself is noun, and hyper is the adjective. A hypertext is a text which is going to have what we saw in the HTML session as well. There will be documents on the internet, and one document will have link to the other document. And then the word for these link itself is called hyperlink. So a hyperlink is a text inside a document which is pointing to another document. Right? When you click on this link, when you interact with this link, you're going to open up a new resource itself. There's a language that will help you build applications that run on HTML, on HTTP. One such language is HTML, and what we have already seen in previous sessions is that HTML itself is hypertext markup language. So hypertext part is common between these two terms. A hypertext, a markup language is going to define hypertext, and this hypertext can transfer over wire. But then this hypertext itself is made for human consumption. And the way we consume these hypertext is through a browser, right? A browser is going to give us those options of, say, seeing an image over here, having a side element, having a navigation section in the beginning, having a footer section at the bottom, right? We're going to have H1s, we're going to have multiple headings, and the way we enclose this is we put all these tags, all this information inside an HTML document. When we request a website on the internet, the browser is sending at least two requests to the server. One is a GET request and one is a POST request. Through the GET request, POST request, the response that generally come is an HTML document, right? And HTML documents, using this, we render things on the browser. HTML and HTTP and browsers, they are made for human consumption, right? But once you have these applications created, once there are activities that you are doing on the server side, like calculation and Twitter, right? You would want to expose these services to other applications as well, right? So what we have seen using the MVC project, we in the beginning of the week, we created web applications. These web applications, they have two categories. One is Razor pages, and the second is web apps themselves. Or if I One is Razor pages, and the second is MVC application, where we add the model view and the controller. The controller is the mediator sitting between model and the view. But these things, these technologies, they eventually generate an HTML document, and that HTML document is transferred over wire to the users. With web services, if we want to consume the code that we have written, and we want other computers to consume that particular service, that or the code that we are writing, we cannot rely on HTML. We cannot send HTML, it will be extremely inefficient, right? And that's why what we need is web services. Now, web services, they are not going to send HTML. Instead, they are going to send a response in multiple formats. Two popular formats that I've used extensively is XML and JSON. Right? JSON is JavaScript object notation. Everything goes inside curly braces. Um, Arrays are inside square brackets, and then it's a key value pair combination. So keys could be in double quotes, and value themselves can be in just the value if it is integer, and probably something in double quotes if it is a string value. But then a document like this, is going to represent a JSON document. I'm pretty positive that you all have seen it, but then let's search for XML to JSON, an online converter. The XML document itself is going to look like this. I'm going to copy this, go up. This is a converter application on the internet. Once I paste the XML here, some valid XML, it is going to generate the equivalent JSON object for it. Right? Notice the size difference. So for 265 bytes of XML, it is generating only 169 bytes of JSON. So JSON is more memory efficient, and then probably in terms of bytes, it is not going to be as effective. So I'm just going to copy and paste it a couple of times over here, and notice the size of XML that is increasing here, and the size at which a JSON object is growing. I'm going to copy all of this and paste multiple times. And after a certain size, you're going to notice that it is better to transfer 48 KBs rather than 70 KBs. So JSON object has become the go-to technology for transferring data on the wire. SOAP services, they generally rely on XML, and they are a little inefficient, not a preferred way. A JSON object is a little more reliable and a better way of implementing a better way of transferring data on the wire. Right? Give me 1 second. All right. So once again, the point is that web applications, they are created for human consumption, and because they are for human consumption, we are going to generate it in the HTML format. And HTML, because most of the consumers, they are going to open up our application, our websites in a browser, and browsers understand HTML. That's why we generate this document. But web APIs or web services, they are created for the consumption of other applications. We have already generated an application. We've already written a web API for consumption. Now let's go ahead and consume this service in some other app, in some other code. I am going to launch a new instance of Visual Studio. Right, and I'm going to write a new project. Let's start with the console application. So I'm going to select console application. Console app. And over here, I'm going to change this to university. Right, and so .NET Core 5 is fine. .NET 5 is fine. So the application is created. Let's just go ahead and write some standard code. I'm going to add the app class with public void run method. And inside the run method, we are going to try to connect to the web API itself. So one option for consuming a web API inside an application is HTTP client. I'm going to type HTTP client, hit control dot, and there's a using statement coming in handy here. I'm going to add that statement. I'm going to say client assigned to new HTTP client. And if we look at the overloads, there are 3 overloads. One that doesn't take any parameter. Then there's a message handler, and there's a message handler with a dispose handler. Let's go to the definition of HTTP client. All right, and notice that it is coming from an invoker and it is coming from a dispose. Now, what do we remember about dispose? A dispose is an unmanaged resource, and if you see a class that is inheriting from, I'm so sorry, it is implementing the disposable interface, then you don't directly consume it. You don't create an object of it. You put it inside a using statement, a using block. The older syntax is this, that you declare a using block like this. The new syntax is that you get rid of these parentheses in the end, and you don't need a block statement anymore. As soon as this object goes out of scope, the using statement is going to call the dispose method on this object. Excuse me. To this client, we are going to issue multiple commands. Once again, let's look at the definition. We have options of delete asynchronous, get asynchronous, and we have batch, we have put, we have post, and we have a send method. The send method is a little different. It is not a verb, but then it is taking an HTTP request message. And if I go to the definition of the request message, you're going to see that somewhere it is going to mention the HTTP verb as well, the method. So when you create this object of HTTP request message, you are going to provide the method with which you want to call, and it takes 2 parameters. It's a nullable parameter that you can assign it a request URI. And with this object created, if you go back and invoke this send function, it is going to come back with a response. So send has 2 overload. One is send and second is send asynchronous. Send is asynchronous is going to return with an HTTP response message task. And this task is going to have, so if I go inside, it is going to have the content, the HTTP content, and inside this content, we're going to have our response object, along with a couple of other things. It has is success status code, and success status code, if you remember from that series of HTTP responses, success response generally falls in the category of in the range of 200 to 299. All right, so 200 series is going to be success code. So let's go ahead and implement that. We have already created the client. I'm going to do client dot get async, and over here you have to pass a URL. I'm going to hit the tab. The URL itself is available to us in the university project. If I can pick up this URL, https localhost 8001, sorry, and we can put it over here in this on this link. Let's go ahead and look at the response. But the result itself, if I hover over it, it is a task that we are receiving. What we actually want is HTTP response message and not the task. We have two options. The first option is .result, but we are never going to do .result because .result is like blocking the thread and calling await on that particular object. From our knowledge of asynchronous programming, we are going to put the await keyword over here. Right? The await is complaining. It is saying that await operator can only be used in an async method. So we'll have to modify the function to be async. And generally, you don't want to leave your async function as void. You would at least want them to be task, or better, you would want to have task of integer. Because we don't have any return value from the run function, we are going to use the task overload. And I'm going to change the name from run to run async. That is a convention so that the consumer or caller of this function, it is aware that they are calling the asynchronous implementation, and then they can do an await and do an async. Now, for this to be async, we'll have to put the async keyword in the main function as well. Right. So once you start calling async function, async is very contagious and it goes all the way up to the beginning of the application. Now, one easy getaway, C#9 only, is this, that you get rid of everything. And because there's a using statement missing, we're going to add that, and that is going to fix everything. So this is the same as the other code. .NET Core takes care of having an asynchronous main created for us, and it spins up this program. So I'm going to leave it at this and come back to run async. We have created an HTTP client object. With that object created, we call the GetAsync method on localhost 8000, and I'm getting the result over here. I'm going to set a breakpoint and hit the F5 key. Our service is already running. Right, the console application has started, and it came back with a result. Now, if I put the result in the watch window, this is what we're going to see. We see that the status code is 200, and because it is not very friendly, I'm going to open up VS Code. Just 1 second. So I launched a new instance of VS Control N. And the reason I like VS Code is because it gives you a lot of editing options. So I'm going to press Control Shift and L. So everything that is under selection is going to get highlighted. It was the curly braces. And when I hit enter, it kind of starts formatting the document. So the result itself is 200. It's saying the result phrase is OK. This is the version, and the content is present in the content object. Let's go ahead and analyze the content object. If I open up content, I see a bunch of headers. In the header, you're going to see that content length is 2577. And I want to see the raw value of it. Right, the content itself is of type text and HTML, but we are not doing HTML, right? We are hitting the API. So why is it returning text/HTML? Let's continue down this chain, and then all these objects, they are going to have a result view object in it. If you open this up, you're going to see value as a string, And the second value is also a string, which is content length. I don't want to look at the headers. I want to look at the content itself. And this is header reason. And in the non-public member, I'm looking for that one object. Right, I'm not finding it, but I wanted to show you that because we have issued the request, because we have issued the request to localhost 8001, we are not going to see the API. Instead, we are going to see this page. And the through content, I was going to show you that this entire string is available in the content element. I'm just not looking at the right place. It is definitely somewhere in the result content, not in the headers. Somewhere in this, probably in the stream. All right, but then I might have to run through the stream and come back with the result. But the result inside this is the actual HTML response. If we want to go and hit the API, we'll have to go to the university link, and because of GetAsync, it is going to come back with this result object. Now, if I, you know what, let's go back to this. Right. Once again, we're going to hit the breakpoint. Come back here. And in the result, I'm going to go to the immediate window. And I'm going to type result.content.read as string. Let's see if await works here. Await operator can only be used within this. So once again, I'm going to stop this and let's change this to say response, and the result itself is going to be an await statement of response.content.read as string async. What I'm doing is the content itself is available as a string object, but then it is not directly accessible. It is this function that we'll have to call. So when I do that, right now, if I print the result, it is printing the entire HTML document. Do you see this? It's not here. Come to this watch part and print the result. And result is this document here. Now, if I copy the text and go to VS Code and paste it here, we are seeing the entire HTML. The doc type is HTML. Then we have an HTML element. Now, one more reason why I like VS Code so much. If I hit Control Shift and L now, I'm just going to select all the /r/n and I can hit the Enter key. So it is kind of replaced. I can delete this double quote in the end, and this is our HTML page, right? I can replace this with a double quote, like this, and all those spots, they have been modified, and our HTML document is returned as a response for this GET request. But if you continue doing this, you will end up creating a browser of yourself, right? We don't want to see the browser. We want to see the API because try extracting out data from this XML, right? You don't want to run through a 60-line file of XML. Right? What we want is a response of that particular API. So we're going to change this thing to /API/university. And now if I debug this, it's going to go hit that API. It's going to come back with the result. And if we look at the result once again in the object, go to VS Code new file, and I'm going to get a little tricky this time. I'm going to select this, hit Ctrl-Shift-L, and then come back and hit enter here. Right, and then let's replace this combination with double quote as well. Right, now look at this response. So this is a little sorted. Right, there's an ID object. If you want to have, say, let's put a tab here. Let's select all the single quotes and let's format it a little. So you can format multiple lines in VS Code, and that makes it very attractive. These are all the JSON object that the service has returned. The web application, the MVC application, is returning an HTML document. A web API is returning a JSON object. And in this JSON object has all the response of that database table. Right. So our application has started consuming the API through this result object. Now we can apply other JSON to object converters, and it is going to generate the object for us in the page itself. And this also goes back to our discussion on SOAP and REST services. The SOAP services, they are very dictating. They're like, we know what parameter we want to accept. We know how to take that value, and we know the data type of these parameters. And when we send you response, we are going to send you response in a specific format, right? You will always consume result as an integer from this particular hierarchy of XML objects, right? You are aware of that upfront because of this document here, which is called Web Service Definition Language. It is going to tell you all the parameters and all the actions that you can take and all the responses that is going to come back with it. A REST is about resources on the internet. It's like when you hit a URL, I'm going to give you a JSON object, and that JSON object is something that you will have to process at your end, and you will consume that. So the documentation for JSON is or RESTful services is a little tricky, and we're going to discuss that in detail tomorrow. But a REST service is coming back with this kind of response, which we can assign to objects at our end using JSON parsers. And this is how we're going to generate our objects. So we have consumed a service successfully using the asynchronous object. There are multiple other options that you get here. You can call the post function as well. With post function, you will have to probably provide another HTTP content parameter. And then this content is once again going to look like a JSON object.